So we start with the unit hydrograph. This is a hydrograph initially having 40 Q as a discharge CFS. This is cubic feet per second. And here the other portion is the hydrograph. This is intensity of rainfall in inches per hour. So 0, say 0 to 0.5, 1 and 1.5. This here rainfall losses, this is rainfall excess. So rainfall losses means phi infiltration. We are not interested in that. We always remove before drawing the hydrograph, because nothing is being contributed to surface runoff or base flow. Base flow is basically from the stream groundwater, and these losses are already being taken while it reaches to the stream. So these, if any losses are given in your example, you should remove them before drawing the hydrograph. So hydrograph basically represent two parts: base flow, groundwater flow contributing to the channel, and the storm event. This is the storm event, and it lasted for 0 to 0.5 to 1 to 1.5 hours, and this is the intensity, this is the duration from here to here, not from here to here. So this total is 4 hours. You look at total, it fall for 4 hours, but excess rainfall generated, excess rainfall means the rainfall which has resulted into runoff, that was limited to this point only, so 2 hours. So I have written here, look at the hydrograph here, 2 hours is the effective time period for which you need to take care. It's not 4-hour storm, it's 2-hour storm for us for calculation. So unit hydrograph is this. There are two components, direct runoff and base flow, and base flow is to be deducted. What is the unit hydrograph? As I explained earlier to you, that unit hydrograph is basically characterization of area, that if similar rainfall takes place, then how much runoff would be generated in future. So we use this unit hydrograph as a tool to understand that how much kind of runoff would occur, how much water would get accumulate, whether that would cause flooding or not, or if it is not being flooded, whether water is sufficient or not sufficient, how big dam should be, what should be the height of the dam, or what should be the size of diversion structures we are creating. So for that purpose, what we need, that we need characterization of area, we need characterization of watershed, we need characterization of catchment. All represent area where rainfall is taking place, generating runoff, and that runoff we are interested in. Runoff we are interested in. The water which runs through the channel, everybody is interested in that kind of calculation. So this is unit hydrograph is simply a tool which gives us the amount of runoff resulting from 1 unit, 1 centimeter of excess rainfall. If it is more than 1 unit, say 2 centimeter of excess rainfall, then we divide every ordinate of the hydrograph by 2 to get 1 centimeter of excess rainfall. Excess rainfall is what? After infiltration, when we deduct all the 5 values, and what remains is the excess rainfall. So that is the excess value. Is essentially a tool. It basically does not represent true value of anything. It does not represent true value of anything, but we can convert this information into useful, meaningful decision making tools, like kind of construction to be done, or kind of height to be created, or like those things. Those decisions can be taken based on calculation done using the unit hydrograph. So this is what it is. Once you know the watershed response to one storm, like through the unit hydrograph, you can predict what is response for another storm. So that is the important thing. We should understand that hydrograph in itself, hydrograph is there, represent a storm, but unit hydrograph represent characteristic of watershed or catchment or an area of which or on which we are drawing the unit hydrograph. These are the basic assumptions which we were through, that effective rainfall is uniformly distributed and so on. So that we have seen also last time. Now this slide you look at, very important from understanding point of view, that how to get the unit hydrograph. We'll do the calculation for one numerical in your tutorial, so that you could understand this kind of calculation. But let's understand this little bit of theory here. Remove the base flow amount from the hydrograph. Hydrograph represents two parts, one base flow, second is the direct runoff. So first we remove the base flow, what remains is direct runoff hydrograph for us. So hydrograph can be divided into two parts, base flow and direct runoff hydrograph. You can understand in that way. Calculate the net rainfall by removing the infiltration, that phi value should be removed, and retention storage, that should be gone like. And what remains then is the total effective rainfall causing the runoff M, and if it is 1 unit, then it's unit hydrograph. It is more or less, then we have to think how to create. So in the next step you look at, scale the new hydrograph units to yield a unit hydrograph for say 1 inch for 1 hour. So this is 1 unit of depth is being generated in 1 hour. But suppose there is only ½ inch per hour. So we are not interested in ½ inch. The depth of water being created, the runoff being generated, excess runoff being generated should be 1 unit. So if it is ½ inch per hour, then we have to take 2 hours rainfall. Are you getting? This is interesting. So what is not important? How many hours it take, but what is important? How much depth it creates. We need unit depth, 1 inch or 1 centimeter. If you are doing calculation in centimeters, then 1 centimeter. If you are doing calculation in inches, foot, pounds, and etc., then inch. So basically, we will do all the calculation in metric system. So this one, if 1 घंटे में बारिश यदि 1/3 है, then we have to consider a storm of 3 hours, so that it is generating 1 inch of rain runoff excess. That is what is the meaning of this unit hydrograph. This calculation given here, unit hydrograph has 1 inches of direct runoff for the storm duration. Now look at here, this 0 to 10 is not the storm duration. This is the base period. This is TB is called the base period. This hydrograph base is not the duration of the storm. Duration of the storm is this. This is hydrograph represents the duration of the storm, not the hydrograph. Hydrograph represents the value through which we are measuring the discharge in river. It can be endless. This base could be endless, but for a given storm, it would be like this. So this 0 to 2 hours of rainfall, and 0 to 1. This is intensity here. 0 to 1, where my cursor is, and hydrograph is this. This is rainfall of 2 inches. Rainfall of 2 inches. And 2 inches direct runoff. Here it is generated from 0 and it is going. This is rising limb, this is recession limb, and going down. This is 2 inch direct runoff being generated. There is no base flow here. Look at, if base flow is given, we have to go to the convert it into separate direct runoff hydrograph and base flow removed. Now here this is 2 inches. What we need? We do not need 2 inches of hydrograph. So we have converted to arrive at a unit hydrograph here. We have to have this 1 inch of excess rainfall volume. So this has been converted. Here we start with 2 inches for 2 hours net rainfall, that is 1 inch per hour for 2 hours. 2 inches in 2 hours. So 1 inch per hour for 2 hours. The storm duration was 2 hours. But whatever is duration, we need total excess rainfall runoff generated as 1 inch, 1 unit only. So to get 2 hour unit hydrograph, we need to divide 1 by 2 inches per hour for 2 hours. So what we did, we have divided this by 2 and we have divided all the ordinates here by 2 to get this unit hydrograph. Now this unit hydrograph represents 1 inch of excess rainfall for 2 hours storm. So this is called 2H unit hydrograph, 2 hourly unit hydrograph for this. This is the lag time which we have defined earlier, last time also, 4 hours. This is taken from the CZ of the excess rainfall to the peak of the hydrograph. Even in previous, this is same. So from the hydrograph, you see here, from the hydrograph to unit hydrograph, this base doesn't change. Base remains same, only ordinates change. This is 0 to 10 here and this is 0 to 10 here. Base we are not changing. What is changing is only the ordinates. Ordinate means the height of this, the maximum intensity. Earlier it was double of this and now we have divided this because this whole system was generating 2 inches of excess runoff over the catchment, over the area given to us. And other things also remain similar. The behavior of this curve also remains same. Only it comes down a little. Now look at this other example. This is a hydrogram given to you, suppose, which is generating 0.5 of inches of rainfall per hour. Then here it is 1.5 and again reducing to 0.5. So, and this hydrograph generated here. But you look at this corner here. This is very important to understand. Here we are starting from 0, but the value of discharge is not 0. Before start of the storm, there was discharge in the river. Means river was perennial being fed by the underground water. So how much? There was some water here. How much? Like almost 100 cubic feet per second. This is 100 and this is base flow throughout. This is base flow throughout. Now, as soon as the storm started here, this point here, it started rising and rising when intensity increased and there was a peak. This is called peak flow and it is 1000 cubic CFS in our case here. This is 1000 here. But from here, the intensity going down, so it has started reducing and again joining back the normal flow in the river without a storm. That is the base flow. So that is what you need to understand here, is that this hydrograph, now we need to suppose compute a unit hydrograph of this. Then what to do? First, we have to remove this which is not contributing, because in the earlier case, in the hydrograph, phi is 0.5. It is written here in the example that your infiltration index is 0.5. Till that point, no runoff would occur. So we have to remove 0.5 centimeter or inch per hour from this hydrograph. So this below portion 0.5 straightway will be reduced. So what is left is excess above it. So next slide you look at. We have removed this whole 0.5, this area, and this is the effective or net hydrograph. I think you are comfortable with this. Now it is generating 0.5 and 1 inch per hour for how many hours? 1 to 2 and 2 to 3, 2 hours, 1 inch of rainfall. So 1 inch per hour for 2 hours, 2 inches. So 2 inches for a 2-hour storm. This twice too big. We want 1 inch total. How much? Total, even if it is for 4 hours. So it is generating 1 inch per hour. Intensity is 1 inch per hour. There are 2 hours. So in 2 hours, how much? 2 inches. If this storm lasted for 4 years, 8 hours, then there are 8 inches of total rainfall. We have to divide by 8 in that case. So look at now the information here. This has been divided by 2 hydrograph, and all the indices which earlier was 1000 here I show you in this was 1000 CFS, and this has been divided all the ordinates by 2, and this is resulting having the same curvature values as this is rising and the recession limb. Now coming to example. Let's see example given to in your tutorial. Let me download your attendance at the same time so that you could read. This example is given. The red ink used here is the given data and the blue is solution. So I explain you how to understand this numerical given to you to draw the unit hydrograph. This is a simple data given to you, that is a time series data. So 0 hour when the storm was about to start. From there we are measuring the discharge on a point on a river, and every 3 hours we are measuring. Look at every 3 hours we are measuring because time is 3 hours. So we are measuring it for almost 48 hours, means for 2 days we measured the data. 45 hours or 48 hours you could do that calculation. So almost 2 days here. And what we measured is when there was 0 time we started measurement, the cubic meter per second discharge in the river was 15 in the beginning. And when after 3 hours it became 35 cumax, then after 6 hours 67 and so on, it peaked to 175, 195 after 18 hours and then started reducing. So this is how we are measuring the discharge. So these all data represents ordinate or y-axis data, and this upper are the x-axis data, time series data. So if I draw this time versus discharge in a river, including what? Hydrograph. This is hydrograph given to us for 6 hour rainfall. This is for 6 hour rainfall. It rained for 6 hours and rainfall depth generated is 7 centimeter. This data is given 7 centimeter. And what else is given? Infiltration loss phi is given 0.5 centimeter per hour. So if this is the loss per 0.5 centimeter per hour, then the total loss in 6 hours, how much is the 3 centimeter? You look at 3 centimeter. Rainfall depth is 7 centimeter. So effective rainfall, how much? 7 minus 3 is equal to 4 centimeter. So this is the rainfall depth is not 7 centimeter. This is because rainfall depth 7 centimeter is total, and we have to deduct the infiltration. For 6 hours, the infiltrated water is 3 centimeter. So what is effective rainfall? ER is 4 centimeter. And what else is given? That a constant base flow of 15 cumax. That is groundwater flow contribution is a constant. Sometimes it is variable. So depending upon the question, you have to look into this. That base flow is given variable. So you can mention variable. Otherwise, if it is constant, you have to remove this from each data. So what we have done here, that after this understanding of this, now ordinates of direct runoff hydrograph, that is deduct base flow. So what we do, 15 minus base flow is 15. It comes out 0 here. At 0 times 0. Earlier it was 15. So we are deducting base flow to fetch. These are ordinates of hydrograph. And now we are calculating these ordinates of direct runoff hydrograph first. Then we will calculate the ordinates of unit hydrograph to draw the unit hydrograph. Now the direct runoff hydrograph calculation is done first by reducing the base flow. So we are reducing base flow from each value. here till the last one. So 15 minus here, 35 minus 15, 20, 60, 67 minus 15, 52, all these are here. Now, these are the ordinates of direct runoff hydrograph of 6 hours. The rainfall duration was 6 hours. Now, the next step, we are asked to drive a 6-hour unit hydrograph. Because the total duration is given 6 hours, we need not to worry that we have to reduce or double this hour. So we keep it the 6 hours same. We will only from hydrograph to direct runoff hydrograph and direct runoff hydrograph to the unit hydrograph. So hydrograph represents the total depth of water 4 centimeter. These ordinates are generating water depth of 4 centimeter, but we need unit depth, that is 1 centimeter. So each of these ordinates should be divided by 4. So I have divided 0 by 4, 0, 20 by 4, 5, 52 by 4, 13, and so on. Approximately I have done the calculation. You could do after decimal 1 point. Not much required because these data are very haphazard. In hydrology and big projects, data you won't get that much precise like we do vernier and screw gauge calculations, not required here. So after decimal 1 digit is enough. Don't go for 3-4 digits. 2 digit even not required. So just 1 digit I have truncated them to whole numbers, all whole numbers. So these are the value of unit hydrogram. I show you the interesting thing that we are interested in this graph only. This is that easy. Earlier, this red is the problem hydrograph given, tutorial hydrograph given. If I show you the data, these data if I draw on piece of paper on which on abscissa like time in hours 0, 3, 6 up to 45 hours are given, I have drawn all those. Discharge up till maximum was 195. I have taken on this ordinate scale 200, discharge in Qmac 100, 200 and plotted each and every value. So resulting graph is hydrograph. This is red line is hydrograph given to you. Now you are supposed to deduce first the DRH of 6R or 6H DRH because this hydrograph is also of 6R. So we reduce the base flow 15 Qmac from each value. So this is a parallel line, but reduced here. So it starts from 0. So mind it that all the DRH would start from the origin. It won't have any initial discharge value. Like this hydrograph has initial discharge value of 15 Qmac, but your direct runoff hydrograph won't have initial discharge value 0, starting 0 and it would end at 0. At 45th hour, it doesn't have any discharge. Direct runoff hydrograph means that storm has stopped and no contribution to the flow in the river. So this is how it appears. Now each ordinate at every level 180 divided by 4 will give you 45. So every ordinate we have earlier calculated in the previous slide, we can mark here and we can draw. So this is unit hydrograph of 6 hour, or you can write it as 6 hourly unit hydrograph. So it doesn't represent anything, but it is characterized for this area for the given problem, that unit hydrograph. Now if suppose what is the meaning of this unit hydrograph? Understand this. Now suppose this is 3 centimeter, 4 centimeter rainfall generated. Now same there is another storm then of 8 centimeters. So multiply this by 8. 6 are 8 centimeter. So multiply, you will get the ordinates. You need not to do the other calculation. This is not that easy to draw with the large database. Large data for say for month or 1 year. This is just 48 hours of data, 2 days of data. There are data belonging to particular river, yearly data available for 10 years, 30 years or so on. So that is what it is. So with this, I think